So we're wrapping up Unit 4 with our final test over sections 4.2, 4.3, and 4.4. Mainly, we are going to be sketching graphs of rational functions. All right, so we are analyzing the function, looking for domain, x and y intercepts, vertical asymptotes, horizontal or slant asymptotes. Is there holes? If so, where would they be at? So the first thing we got to do to tackle that is to factor both the numerator and the denominator. So the numerator, numbers that multiply to be 9 and add to be -6 would be x minus 3 and x minus 3. On the denominator, I have an x plus 3 and an x minus 3. And as you can see, we have factors that can cancel out. All right, so first of all, looking at our domain. Our domain is all real numbers except for what makes the denominator 0. So here, x cannot equal -3 and x cannot equal +3. Even though those cancel out, what that tells us is that we'll have a vertical asymptote at x equals -3, and because we have the same factor in the numerator, this is where we're going to see a hole in our graph. If I look for x-intercepts, the x-intercept will be the numbers that make the numerator equal to 0. So that would be x equals 3. And y-intercepts, when x is 0, I have 0 minus 3 is -3 over 0 plus 3 is +3. So our y-intercept is at -1. So I'm going to start making our graph here. So we know we have a vertical asymptote at -3, and sketch that in here. So that's a vertical asymptote. Oops, I don't need to label that, but it is at -3, and I know that I'm going to have a hole at +3, and I'm just going to write a hole there. It may not be at the x-axis. It could be anywhere that the graph crosses at 3. I'm just going to put it there for right now, just to make sure I don't forget it. I know I have an x-intercept at 3, whoops, but that's where my hole is, so most likely that will be where our graph crosses the x-axis, and we do have a y-intercept at -1. Horizontal or slant asymptotes. This is where we need to compare the numerator and denominator. So I know that my numerator has a degree of 2 and my denominator has a degree of 2. They're equal. So that means I'm going to have a slant asymptote at the ratio of the coefficients. So my coefficients are just 1 or 1 over 1. So there will be a horizontal asymptote at y equals 1. And I'll draw that in. So this is y equals 1. Now I need to determine where my graphs will be positive and negative. So if I pick values, now I'm just looking at the x plus 3 and x minus 3, the ratio of those, to plug in numbers. So I need a number looking at something smaller than -3. And the only other thing that happens on x is I have a 0 at positive 3. And let's just look at 0. I know 0 is going to be a negative because I have 0, negative 1. But let's look at just what's happening around here. But at negative 4, if I plug in negative 4, I have negative 4 minus 3 is negative 7, over negative 4 plus 3 is negative 1. So I'm going to have a positive value at negative 3 to the left of negative 3. And the only place that I would get all positives is at where the asymptotes intersect here. Now, if I'm thinking about down here somewhere, and I could have positive values here, but eventually I would cross into the negative values before I get to negative 3. So I know that this branch is going to be up here. So between negative 3 and 0, so x is negative 2. If I plug in negative 2 minus 3 is negative 5, that's negative, over negative 2 plus 3 is positive 1, so this value in here is negative. And how about somewhere between 0 and 3, like x equals 1? 1 minus 3 is negative 2, over x plus 3 is positive, 1 plus 3 is 4. So this is still negative. So everywhere between negative 3 and positive 3, I've got a negative. And just checking out over here at x equals 4. 4 minus 3 is 1. That's positive over positive 7. So this is positive over positive is positive. So I know that I am going to have all negative values between negative 3 and positive 3. So if I am approaching my y-intercept and then approaching my x-intercept and then continuing on, I'm going to have a positive value over here. So I still have this hole at x equals 3, but here is my graph. All right, on number 2, if I factor the denominator, keep an x on the top, and I have an x minus 3 and an x plus 2, my domain will be numbers that make the denominator 0, like x is 3. So in my domain, x cannot equal 3, and x cannot equal negative 2. At x equals 3, I'm going to have a vertical asymptote, and the same thing at x equals 2, because I don't have a factor that's the same at the top, so I'm not going to have any holes. So let's draw those in. So vertical asymptotes, x is 3, and x is negative 2, and I have an x-intercept, anything that makes the numerator 0, and that would just be 0. So because I have an x-intercept at 0, that's where my y-intercept is as well. If I have an x-intercept at the origin, it's both the x and y-intercept. How about slant asymptotes or horizontal asymptotes? So if I look at my degrees in the numerator and the denominator. The numerator has degree 1, the denominator has degree 2, so the denominator is bigger. And it's bigger by, oh, it's bigger, so I'm going to have a horizontal asymptote at x equals 0. So let's draw, and that's y equals 0. So I'm going to draw those in. I'm going to do all my asymptotes in red here. All right, so I am looking to see where is my values, positive or negative. So I'm going to do my number line. This is at -2. I need to look at 0, and I need to look at +3. So this is a asymptote. 0 is an intercept. 3 is an asymptote. So I'm going to look to the left of -2. So let's look at -3. -3 on top is negative. -3 minus 3 is negative, and negative for the other one. So between the 3 negatives, that's going to be negative. Between -2 and 0. Okay, so what I need to determine is which direction to the left of 0 is it approaching as it goes through 0. And it could be that 0 is a bounce. So we need to look, is it going through or is it bouncing? So between -2 and 0, I have, let's try 1. I have 1 on top, and then 1 minus 3, and this is -1. So this is negative on top, and then -1 minus 3 is negative, and -1 plus 2 is positive, so this area is positive. And then let's choose a positive one to test between 0 and 3. 1 on top is positive, 1 minus 3 is negative, and 1 plus 2 is positive. So it's actually going through my x-intercept. And then to the right of 3, let's choose 4. 4 is positive on top, 4 minus 3 is positive, and 4 plus 2 is positive. So I got all positives here, so this would be positive. So on this side, to the left of -2, it's all negative. So it looks like I'm gonna kind of approach my asymptotes here. To the left of my intercept, it's positive, and then once it hits the intercept, it's going to turn negative. So there's that middle piece, and then after 3, it is all positive. All right, so there's the graph for that one. In this next one, they're asking us to analyze the graph this time, and we're going to see if we can come up with an equation. Even though it doesn't say come up with an equation, I think we can do that. I know here that my domain is all x values except for where I have asymptotes. So it looks like this is an asymptote at -2, and this might be an asymptote at +2. So x cannot equal 2, and x cannot equal -2. And there's vertical asymptotes at both spots. if I look at my x-intercept, and by the way, it looks like I have a horizontal asymptote at y equals 1. But if I look at my x and y intercepts, it looks like the y-intercept is halfway between 0 and 1. So y-intercept at 1/2. And my x-intercept is over here, and it looks like that might be at -1/2. So these are my intercepts. X and Y, vertical, horizontal asymptotes. So let's take this information and look at maybe writing an equation. So the domain comes from the denominator, and I know I cannot have a positive or a -2 on my denominator. So that means I have factors of an x plus 2 and an x minus 2. My y-intercept is 1/2, and my x-intercept is -1/2. And it also looks like I have an x-intercept over here at 4. Okay. So if I know that my x-intercepts are where it crosses the x-axis, I'm going to have a factor of x minus 1/2 and a factor of x minus 4. And also knowing that I have a horizontal asymptote at y equals 1, that means my numerator and denominator have to have the same degrees, and the numerator is degree 2 and the denominator is degree 2. So it looks like this could be a possible equation. All right, so I'm just going to kind of leave it in that form. If you want to look and see what it looks like, put it in Desmos and compare. I'm not looking for exactly the exact points on here, but just something that's really close. So on this one, this looks like this is x-intercept and y-intercept at the origin. So for some reason I had 2 little dots there, but I'm just going to make it one big dot. I know that I have one vertical asymptote. This looks like it might be at x equals 4. So that means in my domain, x cannot equal 4. And that's a vertical asymptote. I know that my x-intercept is 0 and my y-intercept is 0. And it looks like I have a horizontal asymptote. I'm going to say this is about 2. So horizontal asymptote at y equals 2. All right, so what this tells me is on my denominator, I need to have an x minus 4. And because I have an x-intercept at 0, I need to have a factor of an x in my numerator. Let's do that. And y-intercept is 0. The only thing left here is where did I get this horizontal asymptote? And that means if it's a horizontal asymptote at 2, the degrees of the numerator and the denominator are the same, and the coefficients are 2 over 1. So if I put a 2x on the top, they both have degree 1, and the coefficients would be 2 over 1. And that's it. Lastly, we have the inequalities. So this is a third degree polynomial here, and my domain for a polynomial would be all real numbers. I do have x-intercepts at x equals 0, x is 2, and x is -4. So on my number line, I don't have any restrictions in the denominator, but I do have an x-intercept at 0, 2, and -4. So let's test values. Something to the left of -4 is -5. And if I plug in that, I have a negative. -5 minus 2 is negative, and this is also negative. So 3 negatives is negative. Between -4 and 0, let's try -2. I have a negative for x. -2 minus 2 is negative, and -2 plus 4 is +2. So even number of negatives, that's positive right here. Between 0 and 2, how about x is 1? Plug in 1, I have a positive 1. 1 minus 2 is negative, and 1 plus 4 is positive. So this is negative. And 2, something bigger than 2 is like 3. So if I plug in 3, it's positive. 3 minus 2 is +1. 3 plus 4 is positive. So this is 3 positives. So I have a positive over here. So if I decide what I'm looking for numbers that are less than or equal to 0. So those are negative. And it could also equal. So at our intercepts here, we can also include those points in our solution set. So our solution set for negative values are going to be here, which is -infinity to 4, and I'm including 4. And I also have this part right here. And I have a union set, and I go from 0 to 2. And I include both of those endpoints. So that is my solution set. Last one. First thing, I'm looking for my domain, and in my domain I have all numbers except for x equals -2. X cannot equal -2. That would be a vertical asymptote. I have an x-intercept at x equals 4. And that's all I have. So if I put those on my graph, -2 and 4, and I am going to note that I have a vertical asymptote at -2, and what that tells me is that I can never include -2 in my solution set. I'll never get a value for -2. But 4 is an x-intercept, so I will get or I am able to include 4 in my solution set. So let's determine our positive and negative regions. So at -3, -3 minus 4 is -7 over -1. Negative over negative is a positive. Between -2 and 4, I'll try 0. And I get -4 over +2. That's a negative region. And a number bigger than 4 is 5. 5 minus 4 is 1. That's positive. 5 plus 2 is 7. That's positive. And this region is positive. Now I'm looking for numbers that are greater. So I'm looking for the positive regions. And I can include those points that are equal, those endpoints, except for here I'm not going to include 2. So I am going to include from negative infinity to negative 2, but not including negative 2. And I also am going to go from 4 and include 4 and go to infinity. So there's the solution set for that one.